Okay, perfect. Hello, my name is Irvin Bakai. I will be your guest instructor for today. A little bit about myself. I was a founding member of WDB. I was the VP of Technology and Education before I graduated, so last semester, for WDB's first ever semester, like being taught. So that's what I did last semester. I graduated in December with degrees in EECS and bioengineering. And I currently work at a self-driving car startup right now called Embark. And I have had, I guess, 3 years of cloud experience now, if you count internships, research, and what I'm currently doing right now. So now I'm going to be teaching this lesson today. I was supposed to be teaching the first lesson, but sadly my power went out. This was on Monday, so this is when the whole PG&E thing happened. So sadly, was not able to teach on Monday. But Hannah, also my friend and part of a different organization called Clouded Cal, was able to teach you on Wednesday. So that is good. But yeah, today we're just going to be going over the backend fundamentals of how to use cloud to build backend APIs. So I assume that you've already learned about REST APIs and such, and how to utilize REST APIs and what REST actually is. We're just going to be taking those fundamentals and be applying them in AWS, in the cloud, so that you don't have to worry about things like load balancing, server management, and so on, and do everything in a serverless space. So you can think of this as a backend serverless API lesson. So to get started, and you can follow along with me if you already have an AWS account and money, I guess, in your AWS account, but otherwise feel free to just follow along and see what I'm doing. So I guess the first thing, if you don't have an AWS account, you could easily create one over here. It says create an AWS account, sign up for the everything, and then it'll go from there. I'm not actually going to create it, but this is how you can go ahead and have access to your own AWS account. After you go through that process, then you could actually do your login. You want to log in as a root user for now, and that's how you would create or how you would log in for the very first time. So let's go ahead and log in, type in this. I think that's correct. And you will be greeted by the AWS console, which is where you have all of your lists of microservices that you can have access to. So for this specific lesson, the 3 main microservices that we will be using will be API Gateway, which is how you can interact with your API. AWS Lambda, which will be your logic and your load balancing for your API, and Dynamodb, which you could think of as your storage or your database. Dynamodb is also a NoSQL database, so you're not going to be using SQL, you're going to be using unstructured JSON. So those are going to be the things that we'll use for this specific API. So with that said, let's go ahead and go to Lambda and do our own stuff. Oh, one thing to note, if you remember from Wednesday, there's going to be different regions. I'm currently in Northern California because that is the region that we're most closest to. And I would recommend doing the same. However, again, depending on the laws of the region that it's stored in, you might want to do different things like Oregon or Ohio or whatever. For this demo, we're just going to be using Oregon, which will soon be empty. So let me go ahead and delete everything from Oregon for now. And then we can go from there. Delete and delete. Perfect. So this is Lambda. This is where you're going to be storing your core functionality, your core logic for your APIs. Again, just create a new function and then go from there. We will be authoring from scratch, so you could call this any function name. What I want to do, or what I personally would do with my Lambda functions, is call it by the name of the API and then what method it's using. So let's say that the API you're using is like you're adding a new user to your database. So you're querying, let's say, the user's endpoint. Then I would name this users_post.py. Or that's what I would name the file, but the function name would be users_post. So that's what I recommend doing. Of course, you don't have to do it. It's just something that is helpful for me and helpful for CI/CD in the future if you want to iterate across a lot of the different things. But for now, we're just going to build a very basic API and call it post. For the runtime, we're going to use Python because I love Python. Python is great. We all love it. And here's the interesting one, permissions. So AWS has this funky thing where it cuts off certain permissions away from certain users. So if you have a function that you think should work but isn't, most likely than not, it's a permissions issue. So you would probably want to change your permissions, and I'll show you how to do that later on. But for now, let's just create a new basic role with Lambda permissions, and we'll see why that's a problem later on. Advanced settings. Yeah, no, nothing there. So let's go ahead and create our function. As AWS takes its time. Any day now. Okay, perfect. So here is our basic Lambda function. As you can see, it is just literally a function. So perfect. We import JSON and we return this dictionary with a status code and a body that is also dumped from JSON. So very simple Lambda function. Let's go ahead and test it out, see what happens. This is the body request to your test. So right now it just has key 1, key 2, key 3 with like default values, but that's okay. We get to see what this will output. So if we test this Lambda function, we see that it does exactly what we expect it to do. It returns this dictionary with the status code 200, meaning that it's a good request, with the body hello from Lambda, which again was dumped from here. So very simple, very cool. How do we turn this into an API? And that's when we go to our next microservice. So let's go ahead and go to the AWS console again. What I like to do sometimes is just copy paste the link and click AWS so that it drops me directly to the console. Because for some strange reason, sometimes it's really hard to log in, and I don't know why. But anyways, we're going to be using API gateway such that we could actually communicate with this Lambda function from the outside world. So I'm going to go ahead and delete this API, which was never used. And we could go ahead and create our own API endpoints. So there's a lot to choose from. There are HTTP APIs, there are REST APIs, there are private REST APIs, and there is a WebSocket. So we're not going to be using the WebSocket. And of course, since we are web dev at Berkeley, we're going to be using our REST APIs. So let's go ahead and build our REST API. Create your first API. Yay. Let's just do a new API, and we'll call this WDB lecture. Number, I actually don't know what number lecture this is. Let's say 14. Test API endpoint. And then there's something here called a endpoint type. A regional endpoint is basically, this works best for the region that you're on. You have a private endpoint, which only works in your private cloud. And then there's an edge optimized endpoint, which I don't know if Hannah went over, but it's the optimization stuff that AWS does, if that makes sense, with the caching. And if you have any questions, if I'm going too fast, going too slow, drop it in the chat so that I have some feedback on how well I'm doing.
Wait, I'm not sure which API you create. So you create like the private or public one? Because I'm kind of losing that part.
Wait, I'm sorry, say it again.
I'm not sure like which API you create. Is it a public one? Like
yeah, so this is a public API right now. This is just like the wireframe that we're going to do. So like API gateway is just the connection point between the outside world and your logic, which I'll be showing you how to connect later on. Does it make sense?
Okay. I see. Okay, got it.
Okay, cool. So let's go ahead and create our first API. As you can see here, we created a post endpoint. So let's go ahead and make API gateway understand that post endpoint. So let's go ahead and create a method for this post endpoint. Again, since it's a post endpoint, it will be post, and save it from there. Cool. Now we have our first step. Now all we have to do is finish out these integration types. Always use Lambda proxy integrations. It just gives you more information. It's better. Use proxy integrations. And then you could actually choose your Lambda function. So this Lambda function we called post. So that's what we're going to do. Our Lambda region is again Oregon, US West 2. So that is good. We're going to be using the default timeout. So basically, if nothing happens for 29 seconds or your Lambda takes more than 29 seconds to run, then it's just going to give you a, I think 500 error is the correct one. But yeah, it'll just say that something happened in the back end and it timed out. Let's go ahead and create this Lambda function. I'm sorry, there's somebody screaming outside. We love Berkeley. I don't know if you hear that, but it's hilarious to me. Anyways, now we have this actual interface between this API Lambda, or sorry, this API gateway to Lambda. So now we can go ahead and test it out right here. So if we test it, hello from Lambda. We get the thing. We have our 200 status, which was defined here, and we have our latency. Also notice that if you change this 200 to be like, let's say a 500, and then you deploy it. How do I deploy this? Oh, there we go. Sorry, they changed the UI the last time I used it. Yeah, so we deploy this, wait a few seconds to have everything propagate, and then run the test again. We can actually see that it is a, hold up. Give it a moment. Oh wait, let's retest, there we go. There we go, it is a 500 status endpoint. So everything that you deploy on Lambda will be reflected in the API gateway. So now we have some bog standard basic Lambda function. We have API gateway that actually shuttles information between API gateway to Lambda. How do we actually query this? So the main thing that you have to do is now go through usage plans, API keys, and go through the settings and stuff. So for a very basic, to describe these things in a basic format, usage plans basically says, this is how much you can query the API and how frequently you can query the API. So you can set it to 1,000 times per second or just 1 time per second. That's what a usage plan is. Whereas an API key is if you want to give out different API keys to different people, this is where you would create your API key and you could attach usage plans to the API key. So that's how that delegation of information comes from. So in order to actually access this API, you need to create a usage plan so that you could query your API to a certain amount of times per second, per month, so on and so forth, and then attach that usage plan to an API key. And then using that API key, you could then deploy this API and then use it in your actual web development workflow. Does that make sense? Any questions so far before I do it? I know that was a lot of information. It will make more sense when I do it. Going once, going twice. Okay, perfect. I'm just going to go on then. Okay, let's go ahead and create a new usage plan then. So let's call this a basic usage plan. And then let's go ahead, and now you have these options, right? So this is the thing that I was talking about, the quota. This is how many times you could actually query your API per month, per second, per year, or actually per day, week, month. Those are the only things that you can do. For now, let's just do a bog standard 10,000 times per month. These are the rate. So basically how many times per second before you start being throttled or before it starts rejecting your calls. Let's say that we could do 1 request per, or 5 requests per second. The difference between a burst and a rate is that sometimes a lot of people, for some strange reason, just use your API at one time, whether this is during peak load or during a peak time in your API's workflow, and then it just has to handle more than its current rate. So that's where the burst comes in. Let's just set our burst to 50. And then let's go ahead and press next. Add API stage. Let's add it to WDB lecture. Oh, one more thing. You need to add a stage. So what a stage is basically different snapshots or versions of your API. So if you've taken CS61B, you have some basic Git knowledge. or you've actually already learned Git through WDB. Essentially what a snapshot is it takes your latest commit of your API or your latest version of your API and displays it on that stage. So in the realm of software engineering, there are different stages that you want to do. For example, staging is where you would test all of your stages before you actually deploy it to a production stage or the stage where everybody actually uses it. You need to set the limit. Oh, so there's a question in the chat saying why we need to set the limit. Essentially, if you don't set the limit, then you could get spammed and get hit with DDoS attacks, which not only bring down your API, but also brings down Amazon's API. And because Amazon is very safe, they're very cybersecurity focused, they rate limit your APIs. This is just standard good practice because you don't want to get hit with 1 million requests in 1 second and then crash your entire server because you can't handle that. So that's why you need to set the limit to see how many times per second that you could receive it. So let's go ahead and create a stage name. Let's just go straight to prod. We don't need staging. Stage description. And we don't need a stage description. Deployment. Hold up. I need to deploy this API, create a new stage called staging, and then deploy that. Perfect. Okay. So this is now our staging API. Oh, I should have called it prod. Oh, well. This is our staging API. This is now where we could actually invoke that API through this URL. So if you were, again, with the REST APIs, you need an URL to invoke it. This is the URL that you actually query. So let's go ahead and copy this URL. Go on to Postman. Also, have y'all touched Postman yet? I assume you did. Question mark. Okay, I'll just take that as a yes. You have touched Postman already. So we'll call this test query. And then add this to WDB. Okay, so since this is a post,
you like just like quickly explain like what Postman is?
Oh, okay. So Postman basically is a way to interface with APIs. So usually, like in the standard sense, if you want to interface with an HTTP API, you would need to use like a request library, or you would need to basically just send a ping to the server so that you could get something back. Rather than doing it in code, whether it's like through Python or through React, where you would do your getter commands, you could just use Postman to test that for you. So it's just a very easy way to send API requests without actually dealing with the code of making API requests.
Oh, okay.
Yeah. Okay. Cool.
So it's like something I can use to test my code, right?
Yeah. So something that you can use to test your APIs. It's free to use. You just download it. You just use it. I love Postman. Use it all the time to test my APIs.
So yeah. For example, if my API is set to retrieve the data, then I can use the Postman to check whether I actually get the data or not.
Yes, correct. That is exactly what Postman is supposed to do. Okay. So it's a post request. We do post here. This is our thing. Now, quick question. Will this work? Will we be able to press send and get back hello from Lambda? Yes, you have faith. Thank you for having faith in me. Sadly, the answer is no. Oh, it does. Oh, hello? I am shook. This was not supposed to work. Yes, you're right. I should have had faith. You are correct. Interesting. Okay. But yes, apparently it works. And I think I know why, but I will display that later. But yes, once you send your post request to here, you could actually see that it says hello from Lambda. And then let's take this here. Oh God, this is in the way. How do I? Oh, there we go. Perfect. Okay. And again, if you can do it here, if you deploy changes here, then it should be reflected from the API almost immediately. Also, as you can see, we still have 500 internal server error. That's wrong. Let's just go ahead and call this a 200 as it was before. Send. Yes, hello from the API. So as you can see, Amazon is very good at propagating changes very fast. So as long as the Lambda is updated, then it goes to API gateway and does that. So your basic way that this goes is that you query the API. This could be from Postman or the front end or wherever an API is being used. The information there gets shuttled to API gateway, which has its own URL, has all of its resources, for example, this post request and everything and so on. And then API gateway shuttles that request to AWS Lambda so that Lambda can actually do something with the information, and then again returns it back to API gateway, which returns it back to Postman. So that is the basic workflow of how to get an API in AWS. Any questions so far before we start adding more stuff?
Could you say that again? Like, what's the difference between the API gateway and the host Lambda?
Yeah, so API gateway contains zero logic. I mean, technically it can contain logic, but it'll be very, very difficult to do that. But essentially what API gateway does is it just shuttles information from the outside world into your Lambda function. So Lambda contains the core logic, the function itself, whereas API gateway does the actual networking stuff of interfacing with all of the people querying your API.
Wait, so if I have like multiple functions, then I need to build multiple gateway, or I can just share one gateway?
Yeah, so if you want to make multiple functions, then you just keep adding resources. So let's say we want a resource called new resource. Let me make this big actually. Not, there we go. And then enable cores, create resource, and then create a new method here. We'll just call this a get method. There we go. And then connect this get method through proxy integration to our post function. Save. Okay. And then redeploy this API. Deploy API. Deployment stage staging. Deploy. Cool. And then we go to Postman. And well, what did I call this again? I called it something. Oh, new resource, new dash resource. Okay. And then do dash new dash resource. And then query that with a get. Then you would get the same thing, hello from the API. So that's how you would add new methods. That's how you would start expanding your API so that you could include multiple Lambdas, multiple resources, and do information with that. Also, one thing to note is if you type in garbage and then actually send the request, you're going to get errors. This one says missing authentication token. That's just a misnomer. It gives you that error because it doesn't actually exist. That's why it's giving you a 403 forbidden. I'm sure Alex can talk about why you use 403 forbidden instead of saying that this doesn't exist, but that's a topic for a different day. But yes, that is how you would add new things to your API. Yeah. Any other questions so far? Okay, cool. Doesn't seem like there are any questions. So let us go back to our resource. So the next big thing is that I was talking about API keys and usage plans. Right now, it turns out if you don't set an API key, if you don't set a usage plan, and for your API, if you, oh, whoops, press the wrong one. Oh, that's okay. And if you set your authorization to be none, then anybody in the world can query this API. So like if you have this URL, you could actually go on Postman right now or whatever you want to do and actually query this API and do all of that. However, that's not very good software engineering, some cybersecurity controls. So like I said earlier, if you want to DDoS Amazon and DDoS this API, you can very much do that and build a script to like send a million requests into this API. And Amazon will either crash or fulfill it. And if it fulfills it, you pay a lot of money. And you obviously don't want that. So one of the big things is to set a usage plan and API key. So we already set the basic usage plan. Now we just have to create an API key that uses that usage plan. So create a new API key. Save that. So this is our API key. I'm going to copy this because we're using it later. We'll add it to the usage plan, basic usage plan. Perfect. Go back to our APIs, go to our lecture API, and then change our authorization. Then we will no longer be able to access this unless you have the API key. And again, you would change this into here, say true, set that to true. Let's also do that to our get method, since that's also probably want to be secured. Set that to true. There we go. And then deploy this API to staging deploy. Okay, now that that's deployed, it's the same invocation URL. We go to Postman, and if we send this resource, we can see now it is access forbidden. Can you set a key to a whole resource / the whole API? As far as I can tell, the last time that I used this, no, you cannot. It's very annoying. You have to go through all of the resources and manually configure it. Although I can be wrong, I could be wrong. There could be a difference. But as for setting it manually, no, there is no way to actually set the whole resource to be, or the whole API to have that. Again, I could be wrong, but as of 6 months ago, that was the case, which is very annoying. But actually, I'll talk about that later. But yeah. However, if we go to our authorization and give a API key, this is the value x-API-key. We should be able to access it. No, that is not what it's called. Is it called x-API-key? Amazon does this weird thing where if you want authorization, you have to do like x-API-key instead of like something like auth, something obvious like auth. So that is very annoying. Hold up. I forgot what it was called. I thought it was x-API key or dash key. I am wrong. I am so sad. Also, the AWS documentation is very thick and very verbose. So I would recommend like using Stack Overflow for this in case you have to diagnose your AWS issues. The developer documentation is sometimes useful, but it has everything. That's the only issue. It has literally everything. So like up to you on if you want to do that. Is it this one? Actually, what if I just Google x-API-key AWS? Yeah, it should be x-API-key as a header with the chosen API key as a header value. Come on, AWS, what are you doing? Oh, well. But yeah, that is how you would set API keys. AWS is not cooperating with me. That makes me very sad, but it'd be like that sometimes. Okay. So now that we went over securing your API, adding new resources to your API, we can go into how to actually structure the code for your API. So let us go back to AWS Lambda and start actually editing the code in your Lambda function. So one thing that I like to do is create this new method over here called create response. And this just makes it super easy to return responses. So if you set your response here, you could go ahead and set your status codes very quickly. So a 200 status code with a message. Let's say we want to keep hello from Lambda. And let's set our body to be equal to oh my God. There we go. hello. And that. Let's go ahead and deploy. And let us always add new lines, deploy, and test. So yeah, the reason why we want to do this instead is that it makes it so much easier to start shuttling information over and start adding more complicated things like headers, and just makes your code a lot cleaner and a lot smoother, which is something we love to do. Yay for abstraction. So this is one of the basic things that I would add. And then the body itself, if you remember from a previous lesson, would be like in the format of JSON. So JSON is just like Python dictionaries. So in this specific case, your body would just be a dictionary. And then this function over here, JSON.dumps, would just dump all of that into text so that we could actually facilitate that information through our API. So let's go ahead and see that from our API itself. Let's go ahead and change the auth. Not that auth. To be false so that we could get information back. Let's set this to be false again. And go back into this. Let's delete our auths. And yeah, in-hand comparison. Fuck it. And send. Oh, did I not deploy? Yep, you need to deploy. So let's deploy that. There we go. And then let it propagate. There we go. So as you can see, this is our raw message. So it says hello from Lambda. As you notice, it did not actually send the, where is it? There you go. The, what's this thing called? Oh, the message. But that is okay. Actually, I think it did send the message. Let me check. Oh, it did. Yes, hello from Lambda. So as you can see, it's just a very simple way to like start packaging and storing information to all of your requests so that you could send it from there. So that is one of the things that you could do. And again, this is just a standard Python function. So whatever happens in the event and context, you can just do. In fact, one thing that we should probably do is show you what these events and contexts actually look like. So if you want to actually see what this event looks like, let's deploy this change. And then let's see what the full thing is. So you can actually access a lot of information from the events and the context. So as you can see, you get a lot of information from the event. So you could see what resource it was queried from. So we know that it was queried from new resource. We know the exact path. We know what kind of method it was used to get this. We have all of the headers that we sent. So we have all of the stuff which Postman sent. I didn't even know it sent that much. Interesting. We have multi-valued headers, which is just like regular headers, but with more stuff. We have Amazon Trace Ids in case you want to see what kind of like IP addresses are being sent to your API. You have a bunch of these variables that we haven't actually set, so there are none. A lot of request context, which again is the same thing as like this top stuff over here. And even your domain name. So one thing that you can do with your API is that you could actually send one Lambda function to parse out your entire thing and to have a bunch of if statements or switch statements to figure out where your resource came from and to do information based on that. However, one thing that I should note is that Lambda functions charge you on how much time is spent in a Lambda function. So if you have this massive Lambda function that has a bunch of if statements, a bunch of logic in it, then that will naturally take a lot more time to process your information than it would usually be. So it's good practice to usually use different Lambda functions for different parts of your API and assume the data is correct, or if it's not, quickly return an error code, because you want these to return as fast as possible. One, because that's better for the end user, and two, you use less money. So that is another thing about the software engineering of Lambda functions. You don't want to do the thing in Django where you have one giant block of code or one file that has all of your endpoints. You want to have multiple files for all of your endpoints, so your Lambdas run as fast as possible. Does that make sense? It's like a cost benefit type of issue. No questions? Okay, cool. So yeah, there's just one thing to note, that is that if you want to go that route, it's probably not a good idea if you want to save money. So yeah. So those are the first two things. Now, the second thing that we could do is actually store information in our Lambda function and have persistence in our data. And we could do that using Dynamodb. So let's go ahead and log into Dynamodb. Please log in, please log in. Yes, it logs in. Perfect. Okay, so we are in Oregon. We can create a new table. We can call this table name WDB, something simple. And then let us say that the primary key is ID. And we don't need a sort key for now. And we could just use default settings. Also, one more thing is if you use Lambda, it's probably a very good, or not Lambda, but AWS in general, it's probably a very good idea to add tags to your thing. So if you want to add tags like type of project or like what project this is from, then that's a very good idea. In your personal AWS accounts, that might not be a big issue, but if you go into industry and go to a company that uses AWS, they will have everything on AWS, ranging from different products to different projects and so on and so forth. And in like a standard company setting, you might have like 7 stages or like 20 different APIs depending on what the company does, or like thousands of Lambda functions that are used by different things. So if you want to like sort really fast and sort quickly and find the thing that you're trying to edit, it's probably a very good idea to tag everything just so that you know where it's from. But that's just a little tangent. Let me also disable this meeting control. That's so annoying. Okay, perfect. So let's create this. And please tell me these aren't in use. They're not in use. Okay, I can delete these. Delete table. Delete. Delete table. Delete. And delete table. Also, that's how you delete a table. Very cool, very nice, very swag. Okay. Items. So right now we have this empty table called WDB that is stored in Oregon. We could easily create new items manually. So since we set the primary key to be ID, it requires an ID. So you cannot create a new item in our table without an ID string. So test 1. And since this is a NoSQL database, you could store unstructured data. So you can add a whole bunch of stuff: numbers, binary strings, number sets, which are just like sets of numbers. I guess that the name implies. Booleans and so on and so forth. But yes, that is how you add information. But that's sort of boring because we don't want to manually add things to our database ourselves. We want Lambda to do that for us. So if we want to create a new thing in API Gateway where we add new users through our API, then we can do that. Let's go ahead and create a new method. Since we're adding new users, we'll be using the, where's put? Oh, there it is. The put resource. It is a proxy integration. We don't actually have a Lambda function for this just yet. So let's go ahead and create our Lambda function. Create function, put Python 3.8. Cool. And of course, AWS takes its sweet ass time just trying to make a Lambda function. It'd be like that sometimes. Okay, so question in the chat, do the Lambda functions need to be in Oregon too? They actually don't need to be in Oregon, but it is recommended to have your Lambda functions in the same place as your API gateway and have your database in the same place as your API gateway and Lambda. It just makes sense to have a lot of things in the same place as much as possible so that your latency is much lower. So let's say that you have AWS Lambda set up in New York and you have API Gateway set up in San Francisco, then the information from Lambda has to travel from San Francisco all the way to New York, which just adds time to your invocation costs, and therefore adds a bigger bill to your wallet. So it's just better if you have everything in the same place, although not every location has every microservice. So you might have to like skip a few nodes just so that you can have that. But yes, good question, good question. So as you can see, we have our bog basic Lambda function. Let's go ahead and make it a lot more interesting. So I have this example right here. So the first thing that we should do is probably load our body. So if event or if body in events. Let's also add in our own custom create response function to make our lives easier. So if our body is not an event, then we know something went wrong. So we can create a response here. We can send this to be a 400 because the user made a mistake. We can set it to message to that. And we could set, we don't actually need a body, so that could be none. Okay, perfect. So that is the one check that you need. It's just good practice to validate your params, and if not, just return a 400 immediately. Other than that, we can go ahead and start doing our cool stuff. So what kind of information do we want to add to this database? Who wants to add random parameters? Anybody?
Wait, is it possible to like take a JSON file that you have and then like run through it and then add it to your database like through the Lambda function?
Yeah, so that's actually exactly what we're going to be doing. So well, maybe not a JSON file, but a JSON object, right? So everything is shuttled between API gateway, or everything is shuttled between Postman or whatever you're querying it to API gateway in the form of a JSON. So like if you have your body here, where, or you could use GraphQL, I guess, but for now. So let's say that like you have your key value pairings here. Like let's say you have name, me, or where'd it go? Oh, there you go. And then what's a cow thing? Go, but then set this to be bears. Then it's going to actually shuttle this information from Postman or from React or from whatever into API Gateway as a Lambda, or not as a Lambda, as a JSON object. So yeah, we're actually going to be shuttling information as a JSON, and it actually has to be a JSON object. But yeah, but like yeah. So where was I? Okay, cool. So here we have to dump our actual body. So our body is that, and then we can actually start doing something, or no, not dump, load. We have to load our body. Load. There you go. And then we have our body, and then this basically converts it into a Python dictionary. So you could just do a bunch of your dictionary operations onto this data object, which makes your life so much easier. So much easier. Oh my God. So let's say that we want to, wait, let me open up the right code. Verify. Let's see. I'm sorry, my code is a mess right now. I'm trying to find the right thing. Oh, okay. So one of the first things that you need to do is import Dynamodb. So if you're going to be using something, you can import Dynamodb, Boto3, and Dynamodb is equal to Boto3 dot resource. Perfect. And then from there, we could set up our database. So this is WDB, our WDB database to be table. We just called it WDB, I think. So there you go. So what this code means is basically we imported Boto3, which is just AWS. We imported AWS. And then after importing AWS, we use the DynamoDB resource, which it sets up here. And then we get our specific table, which is called WDB. We just call the .table parameter of DynamoDB to be this. Usually, if you're on your own environment, you actually have to specify like what region you're in, or like what API keys you're using, or set up your own API keys. But because we're already in the native AWS environment, it's actually populated for you, and again, it makes your life so much easier, which we love to see. Cool. Now that we have our actual WDB database, we could actually start doing things with our WDB database. So let's say that our name is equal to body of name, and we set go equals body. So this is getting our parameters from that. Now we want to actually add that information into our database. So we could do, why did I make this so complex? Hello? Wait a minute. Sorry, give me a moment. I am confusing myself. Because of course I am. Okay, so you could actually do WDB dot put item, I think, or is it dot put? Oh, actually, I might as well do it here. Put item. Also, you're going to be doing this a lot with AWS because there's just so much stuff in AWS that you're going to be referring to this documentation. So this documentation specifically, basically the Boto3 Docs, is like my best friend whenever I'm like coding in AWS, because it has literally everything. So like you do like Control F and do like put item or whatever, and hopefully it's there. Or if you like type in put, oh god, there's a lot of puts. Okay, the one issue though is just there's again so much stuff that it's going to take some time to like scroll through and find exactly what you're using, but y'all can do that. You're Berkeley engineers, so that's cool. So you have get item, where's put item or add item? A, B, C, D, E, F, G, H, I, J. Oh, there you go. It is put item. Okay, cool. And then you could do put items, and then you have all of your arguments here. Essentially, this is an example of what it's doing. So right now we're doing a resource, not a client, so you don't actually need table name, but then you could add the actual items here. Also, fun facts, my dad just texted me and my diploma finally arrived in the mail. I have been waiting for that for God knows how long. So exciting stuff. Very exciting stuff. Okay, so because you're using keyword args, you could set item to be there, and then you could actually start putting your actual items. So let's say that you have name and then you want to put a name, you just do that. And then you have go, and then you put go. Okay, perfect. And then that's how you would actually add your item. let's double check DynamoDB and see if that's actually what we're doing. If item, we don't need expected. We don't need that. Okay, cool. It's up to you if you want to go look through all of these things. DynamoDB is actually really, really complex. So there's a lot of things that you can do with put item. Essentially, like if you put an item that already exists, you could actually set it up to error. Or if you put an item and it does exist, you could set it up to just update that item. There's just a lot of like nuance into DynamoDB that you could just spend an entire lecture on. But for the time being, this is enough. So yeah, so you could go ahead and put the item, and then you can actually capture that response. So the response is here, and then you could do stuff with the response if you want to do that. One other thing that you do is if you actually get the right response, then you could do this, or you could return create response, set up a 200 because we know it went through, and then say yay. Yeah, so this is like the bare basics of how you would actually use DynamoDB to like add data. So essentially you import DynamoDB, you import your table that you're using, and then you can go ahead and do things with that table like wdb.putItem or getItem or whatever that you want to do, and then go from there. Now, if you want to do the reverse, so let's say we're writing a get method instead of a post method, then the simple thing to do would be rest is equal to wdb.getItem. I spelled item wrong. GetItem, and then you would set the key to be whatever the ID was. So again, going back to our trusty Dynamodb docs, if you go to getItem, where is it? Where's getItem? Oh, there it is. Yeah, so if you go to getItem, then you would set your key to be whatever your key was. So in our case, key is equal to ID or ID, and then whatever the ID is. Also, one thing that I forgot is that whenever you do a put item, it needs to include your ID. So like your item is unstructured data, that's fine, it could be whatever, but you need to add an ID, otherwise it's not going to know how to bind that to your database. So one thing that I like to do is just to like create a hash and then have that be the ID. But it's up to you on how you want to do it. You could just have the ID be your name, and that could be like easy too. Okay, so question on the chat. Can you run lambda function.py via a cloud terminal instance? And yes, you actually can. There's something called SAM, I think it's called SAM, which is basically the Lambda environment, but on your own computer. And that's like super useful for helping you debug and test a lot of your Lambda code and a lot of like the serverless code in general. So like you could have your own DynamoDB instances or your own DynamoDB like database on your own personal machine so that you can test it out before actually deploying it on the cloud. And it's like super, super cool. But also, sadly, we don't have enough time to go through SAM. But yeah, there we go. The serverless application model. You can go through your entire installation here and just follow the instructions on how to set up your own Lambda instances, your own API gateways, and so on and so forth. One other thing that I want to show you is it this? Yes. Okay, cool. You could actually set up a CI/CD pipeline. Oh god, that is not what I want to show you. You could actually set up an actual CI/CD pipeline of what we're doing. So for example, this is how I structure my repositories. Essentially, you have like a lambdas folder, and this was where you would put all of your lambdas. So like user post, user put, vote get, if you have like a vote object or whatever, and then a bunch of your source pages, and then actually have that integrate with AWS such that every time you push something new to GitHub, it updates your Lambda function. And again, to do that, you would just include Boto3. So if you haven't caught on already, Boto3 is super, super cool. And is basically Amazon as a package. And this is actually what everything is built on. So everything that you can do in the UI, you can do programmatically through Boto3. And it's actually recommended to do everything through Boto3, since it's better to have your application as a code rather than going to the UI. But for teaching purposes, the UI is enough. Another question in the chat is, how would you integrate AWS with something like Django? So that is a good question. In that case, you would use EC2. I think Hannah went over EC2 a little bit, but EC2 would be your own little server space. So if you're familiar with Linux servers, or hell, even Windows servers, or actually no, you don't have Mac servers, but like Windows servers or Linux servers, you could actually create your own cloud server and then treat it as such in EC2, which again, sadly, I do not have enough time to go over, but it's actually not too bad. All you would do is, again, go to the microservice EC2 in your Lambda console. You would launch your instance, and then you would copy your files from your terminal on your computer onto your EC2 instance. And then you would open up all of the ports on your EC2 instance to the ports that Django would use. So if you already have a backend API written in Django, you could just drop it in EC2, open up everything, and then it'll function the exact same way. It's like having your computer as like a server.
What if you had like let's say like a part of the backend that was like through this like Lambda function, the like Lambda AWS, and you have like an API for that, and then you also have like another part of your backend that's like Django based. Is it possible to sort of like combine them? Or
yeah, it's actually possible to do that. That's like a hybrid solution. And like if you go to API Gateway, like for the sake of like spinning up it, that is not what I wanted. But for the sake of simplicity, like I taught you Lambda. So basically, like if you want to like build something from scratch really fast, really quickly, you would use Lambda. But if you could actually create a new method that interfaces with EC2 or whatever you store. So let's say we have a delete method and we go to this. You could actually do a new integration type of any AWS service. So let's say that you have your stuff inside EC2. You would actually choose EC2 here. Not the registry, that's not what I want. Actually, no, the registry. Yeah, so you would actually choose your container and then have it redirect to the container and send the output commands from AWS API Gateway to EC2. So you could actually have a hybrid method with this solution, which is actually really, really cool. And actually vice versa too. So if you're primarily Django or Express or whatever backend language that you use, you could use import Boto3.lambda or import Lambda, and then actually call your Lambda function manually inside Django or inside Flask or whatever the hell you're using, and then return and shuttle the information that way. Of course, much more complicated because it's a hybrid model, and of course, hybrid models are more complicated, but it's definitely possible.
Is there like a clear like advantage or disadvantage to that kind of thing? Like,
so the only advantage that I can see is if you have legacy software. So for example, banks have a lot of really, really old servers, but they also want to start using the cloud and start using the cloud much more often because it's cheaper, right? But it's still handling sensitive data that can only be stored on the servers. In that case, you could have an API such that it redirects it. So if you want a very sensitive request, it redirects it to your personal servers, does all of that. And if you have a like regular request, like a service request, then you could redirect it to the cloud. It's possible, but that's the only use case that I can see is if you have a lot of legacy software and you don't want to spend the time to like update it into Lambda. So yeah.
Right. Cool. Thanks.
Cool, no problem. There's also another question in the chat. What are the pros and cons of using Lambda versus just using Django or Express in EC2? So the one thing that I really like using Lambda is just it's super fast to just spin stuff up and have it working for like, let's say a hackathon. So like if you're at like CalHack 6, whenever that happens, hopefully November, but whenever that happens, then instead of just like trying to figure out a way to deploy your code to the rest of the world, you could just build it natively in serverless, and then literally anybody in the world, even the judges, can use your thing. Also, if you're in a lean startup environment, which I have been a part of for a long period of my time at Berkeley, we loved using Lambda plus API Gateway because it's super, super simple to auto scale. And what auto scaling is like if you have like periods of drought where it's just one request per hour, then you only need one server. Whereas if you have like hundreds of requests per hour, then you need to scale up to like 5 or 6 servers. It's super, super easy to do that in serverless because AWS just does that for you. It's really, really hard to do that on EC2 and load balancing. So if you have that on EC2, you could of course set up load balancing servers, but then you'll have to deal with like multi-threaded requests. You'll have to deal with how you have to deal with like race conditions of how if one server finishes and another server finishes, how do you consolidate that data? And it's just like a mess. It's doable if you go about it smartly, but again, it's a mess. So that's why I personally like using serverless instead of just the standard Django and Express. However, again, the pros and cons are for both. So if you are going with a Django app or an Express app, it's also super easy to just like maintain the code. I told you earlier that like with Lambdas, it's a good practice to use a lot of different files for a lot of different Lambda functions so that you could like spend the least amount of money. However, that's just not true with EC2 since you're spending the entire time. So instead of having like 50 different files, which could be hard to manage from a software engineering standpoint, you could just have one monolith API or like a one file that's like 500 lines long. And then it's super easy to like give that code base to a new developer and have them read that rather than sifting through like 50 different files in like 3 different folders. So there are definitely clear advantages to both. It's again just up to your preference, and my preference is serverless, but it could be different for you. Oh, that was a lot of talking. Any more questions? Fantastic. Okay, cool. I'm glad. But yes, I have 13 minutes to spare. There's of course a lot of things that you can do with the cloud, and hell, I'm still learning. But if any of this interests you, Amazon has a amazing series on how to like really, really dive deep in cloud. Like if you just Google learn AWS, you can find so many good resources of how to like actually train and get your certificate. Also a plug for a different club I founded. There's this club at Berkeley called Cloud at California, which just does cloud stuff and like only cloud stuff. So if you want to like take a look at that, that's like really cool too. But for the purposes of like web development and just API development, then you already have the basics and you could just go from there. So yeah, I don't really have anything else to say. So I'm just going to stop recording and just answer questions as long as people are here. So yeah, thank you.